My name's Cameron Kilton, so I'm going to apologize ahead of time, but I'm going to speak in generalities a lot. I'm not going to read the slide. I'm pretty sure all of you guys know how to read, and gals. I've seen a few here as well. But what we really get into is I really want to emphasize, like, everybody knows how important it is for frequency planning and not stepping on your own toes from a frequency reuse standpoint. And we'll get into that, obviously. The importance of RF design right from the word go, site selection, antenna down tilt, antenna selection. I'm going to put some do's and don'ts on here, but don't get too angry if you're trying not to throw things that are hard. So I'm kind of going to bounce back and forth here because I'm just going to speak to a couple different things. But one thing you want to plan going into any greenfield network from an LTE perspective, I'm going to guess that most of you all have deployed Baicells as your first LTE deployment. Is that, throw your hands up if that's your first dive into the fun? All right, great.
Who was first?
Okay. So service coverage is obviously something you always want to determine. That's always the million-dollar question: is how much can I cover with LTE? And you know, the default answer is better. You just get better propagation characteristics out of the modulation schemes and other technology advancements. Kind of the learning curve into LTE is LTE was never really designed for fixed wireless application. So over the last 3-4 years, it's really the carriers, you know, trying to deepen their pockets even have noticed that, all right, mobility, we're just trading customers. You know, T-Mobile's stealing them all from Sprint right now and Verizon, and now Verizon's going to try to steal them back. So they're looking for new revenue streams, and the next thing they're looking at is fixed wireless, to the point where even the larger OEM manufacturers are trying to come up with ways to do that. Now, we are really focused on that particular component to it with things such as mobility timeouts. Typically, you'll see in LTE networks, you're going to run into situations where it's designed to time out after 5 minutes in an active phone. So if your phone is shut off for 5 minutes, eventually the core drops that connection completely. Well, in fixed wireless, we don't want that to happen. We don't want the core just to forget it ever existed. And, you know, and that way it has to kind of takes longer for the device to come back online. So with fixed wireless, we kind of eliminated that timeout function. That's new to the LTE game. Next is obviously capacity, and that's the, you know, you saw some of Jesse's speed testing up there, and that is actuals. Like, we've literally seen 112 megabit to a UE. We just did a test over in the Midwest and got 112 megabit down, and we saw as much as 14 to 17 megs up, and that's with our current Category 4 UE. Then you
Actually, that was with the,
was that the new
prototype
one?
of the new one, because it has a gig port.
That's right. So the new UE coming out, that was the 11, right? The new 11?
No.
That was the 19?
Yeah.
So the new one has got the gig port, so the 10100 port, and I think the new 11 is going to have the gig port on as well. Then of course you got cost. So these are all variables that you guys have probably come up with, making your own business plans. Is you know, we used to say, at least I used to say, is you have capacity, you know, price, and coverage. Pick two. You know, that's kind of how that always went back in the early days. Then of course you got management and all that fun stuff Jesse alluded to when it came to you know, VLANs, you know, some things I pointed out. I mean, my very first thing I said to Jesse when I got my eNode B is like, this damn VLAN's not working, because I ran 2 different VLANs. I ran a data VLAN and I ran a management VLAN on my eNode Bs. Then, you know, come to show, I was like, oh, that's not working, so that's got to be fixed. All right, so I got some other stuff in here. I kind of quickly go over this. So, sorry I didn't put you on here, Dennis, but common platforms that the carriers are using for modeling is a program called Forest Atoll, which is very big in the LTE. Another one's EDX Signal Pro. These are 2 of the bigger programs that the major carriers use because it does PCI planning, does frequency planning, it does cell site selection automatically, particularly when it comes to small cell deployments. That's where you're going to see the biggest uptick in for carrier sales development. Is there's not going to be many more macro sites, big towers. Is everything's they're bringing everything closer to the user, so they're putting it at street level. I'm sure some of you all have even just noticed around here in Memphis some of the street lamp posts set up through the cameras and other technologies, and anywhere else around your neck of the woods. I even see them up in Maine, because I live in Maine, and I have small cells there, which is actually quite surprising for all 30,000 of us. Oop. Important characteristics when it comes to an RF plan: terrain, clutter, and your population. I take all these into account when I'm doing some of my advanced propagations. If you've reached out to me, I know some of you have, for a high-level design, you're not going to get population and full clutter out of me, because that true clutter data costs a lot of money to acquire from data collectors like that. Just for an example, to buy the entire clutter data for the Northeast is about 150 grand for 1 meter clutter data. So I try not to go out and just start buying stuff that I don't use. So most propagation software, and Dennis would probably even correct me if I'm wrong, has at least terrain data at a very minimum. And you may have some high-level clutter data as well as far as the tower coverage is concerned. And I like to lay in, and I think Dennis, your software does this with the 477 with the census block data. So if you haven't got your forms in, I'm sure Jim's probably sent a reminder out on Facebook. Population. I like to make sure I'm designing my network to make sure I'm actually going to put an eNode B where people are going to pay me for it. Naturally, I would expect you guys to do the same.
I think in reality, in the WISP space, people aren't using EDX and stuff like that. They maybe use tower coverage or whatever.
That's right.
In LTE, let's say you're putting your first stuff up like right about now. The leaves still aren't on. What sort of delta should you be thinking about if you're deploying, say, in a leafless time, in expectations of what those leaves will do?
Yeah, I'll cover a lot of that as we get into the deeper dives, but you're always going to be trading off. Do you want maximum coverage, or do you want maximum capacity? Coverage, obviously, that depends on what you're putting on for tilts. We want to make sure we get that full 10-mile range. But if you're really aiming for capacity and you have a very dense urban market, put some heavier tilts on. Really focus that site on 3 to 5 miles. Focus it there, and build another site for something else. That's not always practical. I get that. But you're going to run into it, hopefully, in a growth-based model where you'll accompany that. Field measurements. This is one of my favorite things I used to have my guys do, is after I would launch a site, I gave it about a week before we try to monetize it. My sales team hated me because soon, they kept getting that nagging question: is it ready yet? Is it ready yet? How about now? No, it's not. It'll be ready when I tell you it is. I wanted field measurement data. I wanted to make sure that the design I had was going to be accurate. So I would send guys out, much like I've seen you all do in pictures on Facebook and elsewhere, is I want to make sure that I design this thing for 9 miles, that I'm getting a signal at 9 miles, and it's going to be an acceptable, usable signal. I also want to make sure it's going to work at 1 mile, to make sure I didn't mess up my tilts or my azimuth and things like that. And I get no less than 50 data points of various locations. And with the software that I was using, you can actually import that there into the software, and it will refine the model based on live data.
You're doing 50 data points per sector or per cell? Per
sector. So it took me a full week. I sent a whole crew out, or 2 guys, to do 50 data points per sector. That's me. I don't expect. I don't expect everybody to do that. It's it's not always time consuming, but it's important to get some actual field data. Propagation modeling software, like I mentioned, Force, EDX, tower coverage, Cloud RF, is another one I've used, all of which have their pluses and minuses. The biggest thing, and I don't know if Dennis, you have PCI planning and things like that built into yours. I can certainly share some of the formulas with you on how to do it, and we'll get into why PCI planning is just as important as your frequency planning. And the 2 that support that now are EDX and ATOL. Expensive software. Does anybody have either of those 2? A perpetual license for ATOL is about $40,000, and you own it. But then you have to buy your own clutter data. EDX is about 15 grand a year per seat. So it's not cheap stuff.
Yeah, Cameron just casually dumped the pricing into a message to me.
We're not talking about that right now.
Maybe that's something we can get corporately, China guys.
Cameron, can you give a high-level overview on why PCI planning is so important?
We will get there. It's built into the presentation. I'll explain a little bit more about PCI. It's probably coming right up. So, apparently it's coming right up. So propagation modeling, this is some basic modeling used in LTE world. Most common that you see in modeling is the Longley Rice model, otherwise known as the ITM, or regular terrain model. That's used just about everywhere. It's been around for a lifetime. These other models, particularly the second one down, was really developed with partnership with Ericsson. Ericsson, when the WIMAX thing was kind of coming out, that was the very first crazy model. Then you got Okamura Hata model, which is really designed for LTE in the FDD space. There really isn't a perfect model for our space. Even in band 41, if anybody's got some band 41 licenses, there's really not a good model there. So a couple of these companies made some hybrid models and made it work for our 2.5 and the 3.65 areas. But typically speaking, you're going to use the irregular terrain model, which is pretty standard. And I think many of the online ones that are today use that. All right, PCI planning. So this part's going to be fun. Not really. So I want everybody to understand what PCI planning is by the end of this, hopefully. And please ask questions along the way. Stop me, throw your hand up. I'll call you out. If I don't call you out, yell at me, and I'll still try to call you out. You get PCS and SSS, so, or excuse me, PSS and SSS. So it's broken up into two spots. The PSS is 0, 1, 2. Those are the three. Then SSS is 0 through 167. These are all mapped. You see the PSS between subframes 0 and 5, mapped on the subcarriers and OFDM signal 6. That really means a bunch of nothing to most of you, and you don't need to. Just don't. It's not worth the time and effort to pump into it. Just the important part is why PCI is going to be important. Then obviously you got the SSS subframe 0 and 5 as well. So these synchronization signals for PCI, the PSS and SSS, are transmitted every 5 milliseconds. Now this is part of when I talked about the UEs always looking for a best option. That's kind of part of that synchronization signal. The ENOB is transmitting it out. It says, hey, this is what I got, this is what I'm capturing. It could also be hearing another one, this is what I'm capturing. Talk to me, talk to me, Goose, what's the best signal? That's kind of more of the same I just talked about, but it's all in essentially one slide. So there you go. Take a picture, steal it if you need to. All right. So you'll notice a similar photo. Jesse actually had this photo. He probably copied it off some of the same stuff I did down here at the bottom. So this represents essentially 3 sector sites, with 3 different PCIs. Which one is the laser pointer on here? That one? Woohoo! So site 1, 2, 3, and 4, we'll call it just for sake of math here. 0, 1, 2. I'm going to go, I use the term alpha, beta, gamma a lot. If some of you guys are familiar with the cell industry, that's essentially how they identify their sectors. Alpha is always closest to the 0-degree heading. Beta is closest to 120. Gamma is closest to 240. So you notice that 0, 3, 6 are all facing towards, we'll call it 0 degrees. We're going to pretend straight up is true north. Those won't interfere. If you have 3 and 0 pointing to each other, even though they're on a different PCI, because they run on the same subset on the PSS frame, they'll cause interference, which seems illogical because it's not a frequency. But the timing will get messed up between cells and it will get confused. Kind of a self-explanatory slide. PCI should be avoided within the same site. So please do not run the same PCI on the same site, like 1, 1, 1 on one site, because you're thinking that's logical for some people. This is site 1, so all my PCIs are going to be 1. This is site 2, all my PCIs will be 2. Don't do that. Especially if you do PCI lock, your UE is going to have a conniption fit on which one to try to attach to. It's going to have no idea what's going on.
We suspect the issues related to PCI planning and PIM probably take up a lion's share of a lot of the issues people are seeing. So
yeah, absolutely.
We can't stress the understanding the PCI part
the best
too
way
much because, I mean, it's so alien to how you normally have built your cells if you're using, Cambium or Wi-Fi or anything else. It's a whole alien concept.
The best way I've explained it as far as PCI is comparing to running a tower site with 6 sectors, all the same SSID, and your tower tech's trying to figure out what the hell's going on sometimes. We all used to use MAC address lock back in the day, We've used, best AU features and some of the other ones, but it's very similar to trying to run the same SSID across everything. All right, so this is a little cheat sheet, and I'll share this with anybody who asks for it. I made a cheat spreadsheet, so feel free to get after me. I'll give you one of my cards. You can email me for it. We'll probably post it online, of kind of PCI planning in a nutshell. So you see up here, I got site, sector, heading. And so I always use a true heading. PSS, SSS then formulates the PSI. Now, A, B, C, D, A, B, C, D, E, G. So this is the formula that you use to calculate the PCI in an Excel spreadsheet. So essentially, every time with the E column, which is the PSS, you're multiplying by 3, then you add the SSS, the equal PCI of 3. So the very first one, site 1, sector 1, the first PCI is 3. The second one is 4, 5, 6, 7, and 8. Now you notice the PSS column is kind of the important one here, and this is how you can get away with it. You see how you have 0 on sector 1, and you have 0 on sector 4. The obvious thing there to me is the headings are completely back-to-back. And that's what you want to make sure when you're shifting your PSS, so your headings are back-to-back, just like an AB frequency scenario. Right? If you're lucky enough to have 3 channels, ABC, ABC, which is this represents a 6-sector site. So I made this spreadsheet basically for the 3 common examples, a 6-sector deployment, 4-sector, and 3-sector deployment. 3-sector is obviously the easiest because there's only 3 PSS signals. So you have 0, 1, 2, and there you go. So you always want to make sure, even with your neighboring sites, so you don't have a PSS of 0 facing each other. You want to make sure, or in the same alignment with the CPE. So if it's, you really got to think about it, you got to map it, you got to stick it on Google Earth, whatever it is you're using. If you have a UE pointing a direction that could hear multiple sites, you want to make sure that it's not hearing a PSS of 0, 1, or 2 from 2 different sites coming at you. That can cause yourself some headaches. It can cause the site some headaches. It's going to lower your capacity. Yes, sir.
So we have talked about this amongst ourselves, and I've seen it pop up on Facebook. The PCI, if you have an option to put different PCIs facing either direction. If you have a different PCI facing either direction, can you use the same frequency 180 degrees out from each other on the tower? Is that working, or do you have to have each panel on its own frequency?
No, you can go AB, AB. You can go if they're back to back. If they're literally back to back, I would discourage it. You're going to have some problems. But if you have some good horizontal separation, an AB configuration for frequency reuse 1, totally acceptable. I'd expect nothing less.
So what do you guys recommend as a vertical height separation?
Vertical height is not necessarily as important necessarily on a back-to-back as it's going to be your horizontal separation. Because if the radios are too close to each other, for example, literally back-to-back.
Like on Roan 25, it's not going to work.
Try to put some standoffs in. I'd say 3-foot standoffs on either way, have some separation. You're still going to have some overlap, but you don't want those puppies sitting on each other.
Cool.
Obviously, Roan 25 is probably the common deployment if you're fortunate enough to have some bigger towers. Obviously, I get it, but I built plenty of 25s myself, so I understand. But try to put some standoffs on.
Luckily enough, our new towers we're looking at is old AT&T towers, so we got like 20 feet at the top.
So I actually, when I built up in Red Zone and did that network, I was pretty much on American Tower, Crown Castle if I absolutely had to, because they're absolutely horrible to work with. And SBA and all those other guys. So I've been on all the big towers. I've also been on the little ones. With the big towers, we always had to use sector frames. They had a 7-foot face. They stood off the tower another 6 feet. So I had almost 12 to 14 feet of horizontal separation between my sector arrays. That's obviously what the carriers are doing, and it's for a good reason. Nothing isn't without its thoughts. Now, any questions on this? Guys, I do not expect you to get this necessarily right now. It took me 3 or 4 days of constant studying to really understand the whole concepts of PSS and SSS. Yes, sir.
Whatever, and just use those uniquely, would that actually solve the problem, or is the math important?
No, you got to follow the math. So I hope you paid attention in high school. I know I didn't. So follow the math. The math will be your guide in this case. This is why your PCI is just as important as frequency, and I cannot stress that enough. And it doesn't seem like it, but it really is that important. It can cause you a lot of headaches that none of us want. We can create enough of those on our own. So if you want a copy of the spreadsheet, just see me, give me your email address, or you can email me, cameron.kilton@baicells.com. Shoot me a note, I'll send you the spreadsheet.
By the way, you'll see Rick on this side and Armando on this side floating around with the mics. Your questions are important, not just to you, but to the audience. So I want to make sure that the video captures them. So please, raise your hand and give these guys a little bit of time to get the mic to you before you ask your question.
So does this come into play with X2
Art,
handoff?
did you just hear what I said?
That's all right. I'll repeat the question and take in Patrick's hints as well. So does this come into play with
Go
X2
sit in the
handoff?
corner.
X2 is primarily a mobility function. I personally, and this is me airing the dirty laundry, I think PCI lock is a crock of crap, personally. I think that's a workaround for a bad problem. I think X2 will be solving a lot of those problems. Mobility doesn't have these issues with things going seamlessly from site to site. Neither should we. So let's figure it out. So that's what I'll be working on as well with the team, is we want to make sure the handoff is seamless, the data connection is solid, and I don't want to have to worry about if I have 6 sectors on a site. If one sector goes down, I expect my customer to move over, stay online. That's one of the benefits of LTE. Yes, sir.
See how Cameron fits in so nicely with the blunt talk that I like?
Yeah. I've lived in it, guys. I sat right there 2 years ago when I first dove into LTE, scared shitless what the next step was going to bring, because it was a big step. However, this is probably the easiest system I've ever deployed. I've shipped it out to 3 different private EPC companies, and they had it up and going in less than 30 minutes. I have 2 at my house. I have a Band 41 and a 365. I had it going in an hour, and actually my son configured the first CPE, and he's 11. So, yes, sir.
By running in LGW mode, don't you screw up a lot of that roaming capability? Because if you're in routed mode, you're going to pass out a different IP address, and if you're in NAT mode, you're going to have NAT translation problems.
Yeah, you will need a core. Yeah, and this is where the local EPC, I think that was the lone question in the box out front, was local EPC. And I am a big supporter of having your own EPC for reasons that I can go probably another 2 hours on of why it's important. The cloud EPC is great if you're coming into this. You have one vision in mind, that's providing internet. But having your local core opens up the possibility to IoT devicing, selling private networks over your LTE network with APN. Private APN is exactly, I think the question you asked earlier today is huge. I love it. I ran multiple APNs all the time. I could sell it to the water company, sell it to the electrical company. Say, here, you're going to have your own network. You can run your own smart metering system off this network. It's virtual right back to you, hands off. I'm going to carve out a sliver of prioritization in one of the bearers that Jesse was talking about. And all that's achievable with a local EPC, not a cloud EPC. So if you open up your vision in the LTE marketplace, it can be much broader than just providing fixed internet to anybody. You really can open up your potential sales opportunities to be significantly bigger, your customer base opportunity to be huge.
Yeah,
LTE
and even
has a
though
lot of
there's
value.
maybe one index card in the box for that question, I know there's a lot more people with that question bouncing around in their heads. Know that in other markets outside North America, people are running off our locals, so running VMs with our software. So our issue in getting it commercialized here is just getting all the documentation and all that kind of stuff right, and then making sure guys like Cameron and Jesse can pound on it a while. And I don't want to make people guinea pigs.
Yeah,
It's basically that simple.
Yeah, as far as EPCs are concerned, if you're going to have your own local EPC, I know I mentioned, sure, I think you said you had one over there. What brand are you using, if you don't mind me asking, if you have an EPC? The 2020s? Yeah. How you liking them? I had 3 break already, so. Makes you drink? Me too. I lost a lot of hair, in case you couldn't tell. No. There's a lot of third-party EPC vendors out there, and that's what they do. However, just much like us, they're subscription-based modeling. All right, so they can either charge per user or they'll charge per sector. You kind of got to pick up which way you want to go with it. Say what?
It sounds like there'd be an eBay model out there.
There probably could be, but yeah, I think we've all had our experiences with eBay models and how that can treat networks.
We do have some favorites, we'll say, and take that question to Cameron kind of offline,
Yeah.
and it's a company that we're developing actually a strategic partnership for other things, but
And that's
they
what
have
they.
a really
I'm a big.
interesting solution.
I'm a big proponent of actually a third-party EPC, and I'm sure some of my Baicells colleagues will probably kick me for it. I want to sell you hardware. That works. The EPC is kind of a side thing for me, all right? But I want an EPC that's going to work, and as an operator, putting myself back in your chair, I want an EPC that will work with anybody and doesn't care who the hardware vendor is. And that's who that I recommend. Because, as much as I'd love to sell you only Baicells, I know you're going to play around with something else. Like, how many people have Ubiquitys play with Mimosa, and how many people have Mimosa play with Ubiquity? Anyone want to give me a quick hand show there? Just about everybody. Like, we know we're always looking for the cool, new, shiny toy that's going to give the customer what they want. And our EPC, for all the feature sets that it really needs to deliver, isn't there yet. I'm not going to lie to you and say that it is. But getting back to, I can literally sidetrack on a million reasons why you want your own EPC, but I really want to emphasize this, and I cannot say it enough. PCI planning, treat it as if it's the most important part of your network, because it is. As you start building your network and your LTE network, you're going to start running into, all right, I just built a metro. Now I need to put some small cells in because I just filled up all the capacity on these sites. So let's offload with small cells. So your PCI planning is really going to take into account the importance of your network, as well as obviously frequency planning. Yes, sir, you got a lot of questions. I like it.
The small cell, are y'all using the same feeds for the Omni antenna, or y'all have a different?
So we'll cover small cell later, just before the roadmap, because it's actually the majority part of the business for us globally. And I think it's a concept that becomes extremely relevant to each and every one of you very soon. So we'll cover small cell in detail here today.
Small cells are something to be really excited about. They really are. That's really what I want to
We do some really interesting small cell stuff.
I mean, you're seeing all the carriers, and I'll speak just quickly to small cell on that sense. You're seeing everybody, they're bringing their devices, the base stations, closer to the customers. And that's for a reason. That's for capacity. Even in Maine, where I am, I've seen 5 rooftop sites that do not carry a single drop of voice. They are data only. A very data-hungry world.
Our small cell business globally is so hot that in Mobile Wireless Congress in Barcelona, SK Telecom, which is Korea's biggest, China Mobile, China Unicom, Intel, and Qualcomm all had it in their booth, our small cell. And I'll explain some of that stuff later.
Yeah, it's exciting. Definitely stay awake for Patrick's part again. All right, has anybody got any more questions on PCI planning? Please ask it. It's a great time. Yes, sir. Hang on a second. I got to follow the procedure here. I'm going to get yelled at. I'm just gung-ho.
Yeah, so I'm just curious, where do you go with site 4, 5, 6? Does your SSS, how high does your PCI number go?
Your PCI never goes higher than 0, 1, or 2. Oh, excuse me, the PSS. Your PCI goes all the way up to 504 is the maximum configuration. So the next question would be, if I was you, what do you do once you get to 505? You do have to reuse PCIs. There's no question about that. You just got to be careful where the hell you're reusing them. You can start reusing them right away. But I would say always plan your site like it's going to have 6 on it, because then generally speaking, you're probably not going to get into a situation where you're going to get yourself in a pickle trying to find PCI. So I would use that very first example for site 1. I would copy it again for site 2, and you can see how I'm incrementing the numbers. 0, 1, 2, all the SSSs are 1. 0, 1, 2 for the second set of sectors are 2. So when you get to your third site, it would be 0, 1, 2, all your SSSs are 3, then 4, and so on. Eventually, it took me a while to get this concept in my head. Like, I got it explained to me probably by 5 or 6 PCI gurus that I have a lot of respect for, and I was just like, boom, could not figure it out for the life of me until I really had to get some visual representation behind it to validate what they're trying to explain to me. Yes, sir.
Is the PCI number, I'm assuming if we're in, say you're 50 miles from one tower to another tower.
Yep.
That's not going to make the problem, or is the interference issue in the cloud?
No, the interference is physical.
It's physical.
It's physical. It's not a cloud interference at all. However, 50 miles is not a realm of possibility. We've all probably done some pretty long microwaves. My personal best is 37 miles. But with that said, that doesn't mean that the signal is not going to keep going. So you can still hear it. So make sure your RF planning, which is kind of what we're covering, is tuned for the market you want. please stop pointing your antennas at the horizon. Which kind of goes into my next point. Antenna choice is very important. Very, very important. And I think somebody made a comment on Facebook on the Baicells page. I know they did, and I wanted to give like 3 likes to it. Cheap antennas versus good antennas are a difference. I don't care what the specification sheet says. There is a huge difference. All right? Don't get me wrong. I'm a big fan of Ubiquiti. Their antennas suck, every one of them. However, I do like the new HD 90s. Actually, they're actually not that bad. All right. LTE 3120s. Anybody got this set up now? You? There's one. All right. Do you have any problems? Yeah, you're lucky. 310s? You running 310s? Okay, you're good. Yeah. Don't try to use a reuse situation on 3120s. You're going to have a headache. It's just, you just look at the coverage overlap there. It's huge. That's a huge overlap. All right, and that's actually a pretty lazy representation of it. Actually, those things cover like 180 degrees. They're pretty ruthless. I would prefer you do this. If you're going to get away with just doing 3, try 90s. And I know you're looking at that gap out there. It's really, these patterns are never perfect, ever. They look good on paper. We've all seen that. We've all seen you point an antenna at 0 and you've been directly behind it and it works magically for a mile with crappy antennas. So that is a good example of something I would support. I wouldn't encourage. That's more something don't do that either. 490s, too much overlap. 465s is something I would encourage. You can do an AB scenario. You'll get 20 megahertz channels out of your block, preferably if your frequency planning is correct. You'll maximize your capacity and coverage pretty well with a 4-sector setup. And overall, you're going to get higher gain out of using a 65 versus a 90, so you get better penetration. Yes, sir. Oh, hang on. You got yelled at once, so you got one freebie.
In band 41, are you going to support ICIC so I can use frequency reuse ones with this?
Absolutely. I'm a band 41. I'm very excited about band 41. I was going to say something way more inappropriate, but I love band 41.
Any idea when you'll have ICIC support those?
We'll talk about that shortly in the roadmap today. But yes, ICIC is important, but I'll talk about it briefly. So don't get too excited about ICIC. There is always a cost to having something cool and new. With ICIC, you lose a little downlink because it has to take one of the frames for the downlink frames and replace that with something to tell it what the hell the ICIC is. So you're replacing a downlink frame with an ICIC frame. That's the easiest way to explain that. There's a way more complicated technical reason, but that's the quick way. This is my personal favorite. This is what I chose to do on most of my sites in Maine. It's very expensive. I contracted all my tower labor because it's American Tower. I didn't want to do the whole gamut and as far as insurance and tests and all that other nonsense. ComTrain was long enough. This is my personal favorite from a construction standpoint because I am maximizing my coverage right away. I am maximizing my capacity right away, and it's built for growth. Obviously, this doesn't work. And if you only working to serve 20 people, 30 people, whatever that model may suit. This is obviously more of a metro type design, but this is what I did in most of the state of Maine when I built it. I only did 2 4-sector sites. The rest were 6-sector. I went in guns blazing.
And Alpha's coming in later, and they're going to share. They have an interesting new design actually, which is kind of a 3-sector single mount arrangement, and each sector is actually 2 33s.
Yeah.
So. Really interesting.
Yeah, so these are 45 degrees. I actually, if you can find them, they're hard to find at CBRS, but we're working with antenna companies now to make them. Is really 30 to 33 degree antennas. Now, the trade-off is obviously you tighten up the beam width, you have less overlap, but obviously every time we sneak down that coverage pattern, we do increase the dBi gain. So you're really trying to, you really want to make sure you're maximizing your MCS levels. So getting the most gains to your customer as you possibly can makes a big difference in those MCS, keeps your cell capacity up, and your A utilization low. You might just leave your hand up. We just stick it right up on the wall.
This is using the model that, north and south is on the same frequency, and, northeast, and all your panels that are 180 out are on the same frequency?
That's right. Yep. You always want to be back to back as much as you can if you're going to go into a reuse situation.
Can you do 20 megahertz on that?
I wouldn't. I'd go 15, but you're going to trick question. We don't have 15. That's right. That's coming. You don't think it's not. That's something I've been wanting. And you two are competing. Right now he's up by 2 questions, though. Do we have a prize for that?
Even if you supported 15, how would you do it on that deployment? Don't you need guard bands with your
Not really.
deployments?
There'll be enough support between that and ICIC as long as you do this right and your azimuths are good. I cannot stress making sure your azimuths are on point, no pun intended, to avoid that situation. But yes, I'd go 15s, ABC, ABC, front to back configuration. Anybody else while we're on this beautiful flower of a slide?
By the way, this gentleman.
How many
over
people
here-
throw their sectors up without using a compass or some other type of measurement to get your azimuth correct? Probably most of you. Yeah, that looks south.
Is anybody using contractors to have your stuff put up? Tim? Make sure you get an azimuth report. That should be a part of your closeout package. So don't settle for anything less. If you guys are using contractors, I would be asking for full line sweeps, full PIM, full azimuth readings as part of your closeout, and obviously photos. Don't accept anything less because you want documentation of everything that was there, including the signal levels before
Rick?
they hung it.
Sounds like another buy tip.
You're going to be buy tips for days. All right, so there's some generalities here. Obviously, I want to go back through this. Some of you are probably running 490s now. If you wouldn't mind, put a quick show of hands. Okay, don't feel bad. All right, are you running 20s? You're running 20s? You having any issues? You're one of the fortunate ones. How many customers do you have on that site, if you don't mind me asking? Close to 70? That's not too bad. That's not too bad. All right. Good. All right, so one thing that I preach a lot is down tilt. If you're really going to have a lot of sites in, be careful. Be careful of the antenna you select. You really want to try to find an antenna that can have a variable electrical down tilt setting. Something that usually has got a screw on it, and you turn the screw and it'll change the electrical down tilt configuration. The reason I say that is when you change your mechanical down tilt, you change your front to back ratio. That does have an impact. So if you're going heavy mechanical down tilt, say 8 degrees, I had some sites that were 12 degrees. It look like they're pointing at the ground, but they're actually serving a great purpose. It caused me problems because I wasn't accounting for the electrical tilt issue. So I messed up my front to back ratio, caused myself some self-interference, quickly rectified, but it made me get up there and go, all right, let's pull that back to maybe 4 degrees mechanical, and we'll go to 6 degrees electrical, some flavor of that setup. So something to keep in mind too. So if you're looking at antennas, and high quality antennas will have a variable electrical down tilt option. Ones that I like that do that today, Alpha, RFS, a couple. I even think CommScope makes a couple that do that as well. That have essentially it's a Allen wrench that you can electrically modify your tilt by 0 to 7 degrees. RFS has one that goes 0 to 12 degrees even. Not cheap though. So I'm not going to lie to you and say they're cheap. They're $600 to $1,000 a whack, depending which one you get. Any questions?
I have one question.
Yes, sir.
I just want to ask the audience, who think we done good by bringing camera in here, into our company?
All right, thank you. If you didn't, you can keep your hand out. I will be available, obviously, during break and lunch. If you have some more direct questions you want to kind of get after me with, or tell me I'm wrong, I'm fine with that too. I take criticisms very well. It just come with some good information. Otherwise, be prepared to defend yourself. Yes, sir.
We have 2 90-degree sectors.
Great.
I've got them separated 90 degrees, obviously, because not thinking about all this overlap. Where should I be placing that second one at?
Pretend they're 120s, separated by 120 degrees.
All right.
Yep. Yeah, so that's a good thing. So pretend that your 90s are 120s. Your 120s are basically 180s because you saw the pattern back there. That's horrible.
So you just expanded your coverage 30 more degrees.
Yeah, true story. And you're going to get a higher gain anyway. So, yeah, so pretend these are 120s. You see I built it as so. And even just so you guys understand how tight the carriers do it, In a carrier deployment, 3 sectors, they're doing 3 sectors for 360 degrees using 65-degree antennas, and they get 360 coverage. All right? So keep that in mind. Like, this does work, and these are 90s. And again, 4 sectors. So I would, I prefer 465s, and even that pattern, they're very pretty looking because obviously it's for a presentation, but if you see the true pattern, it looks a little bit more realistic. Okay. I just wanted to put this up here. Patrick kind of said take it out. I was like, nah. It's something that's really cool to me. So this is a macro coverage in 2013. This is actual, it's not as cool as the light switch thing. This is actual gathered data from all the carriers. What we're looking at for tower sites, essentially, throughout the country. It's 2016. All right? That's obviously layering some small cells, but you can see the data requirements have gotten exponentially huge. Now, how many people consider themselves in any urban markets? Only 2? That's a WISP, if I've ever seen one. All right.
Define urban.
Well, by my, I live in Maine, so urban to me is anything bigger than 15,000 people. So anything bigger than 15,000 people in your given town, that's an urban deployment. Think of it as such. With, kind of lost my train of thought there going into it, but with a particular urban deployment, you got to be, cognizant of what you're getting into, because you know what the capacity is. Right now, it's 32 active connections. They'll be bumping to 64 or 96. I know where I was getting into. If you are technologically savvy with APIs, there's a really cool function to know where your customers are going to be. It's Twitter. Twitter has public data, social network that you can download that shows you where the users congregate. It's a really cool tool to take advantage of if you're doing network planning. And maybe that'd be some cool Dennis could integrate into his site. So that's something to take in mind. Like, use the technology that's out there. If you're very familiar with working with APIs, go get this data. It's free. It's telling you where your customers are going to be. If you're ever developing, mobility support, and CBRS is really going to be big. You guys all heard LTUs coming, and we all probably cried a little bit knowing the carriers are going to be playing in our wheelhouse again. It's coming. So now let's take it away. Let's embrace it. Figure out how you can build that network before they do, and sell it back to them. Because if you're doing LTE, you're doing a standard. They're ready for a standard. We love standards.
Which, oh, by the way, you did at Red Zone, right?
This is exactly what I did at Red Zone. So had we signed an agreement with one of the carriers, and based on the data throughput calculations, here's a number that's going to grab you a little bit. We would have made $32.3 million last year in roaming at 4 cents a meg. It's a pretty cool number. Anybody get excited about that? I get a little. If you think they're not, you're fooling yourself. They're going to be playing in CBRS.
Yeah,
they're going to be playing in 5 gig. They're going to be doing offload. And this is my favorite product that was announced in Barcelona. Neutral cell.
I'll talk. Don't go there yet.
I'm not going to go there yet, but it's cool. I'm very excited.
I don't have much cool stuff to talk about today, so that's a big one.
But yes, they're going to be playing with that. So if you guys are designing, and kind of going back to what Jesse talked about with the PLMNIDs, the PLMNIDs is basically a unique number for you. So if you get your own EPC, do you have your own SIMs, or are you getting Telerad SIMs? Yeah, I can get you a contact. You can make your own. You can burn your own SIM. There's I don't know if I put it on here, but Ericsson essentially runs this. There's a website called iConnective, ICONNECTIV.net. That's where you can go and you get your own PLMNID. Every carrier has their own.
Right.
I had my own.
You cannot use the cloud if you're doing that.
You cannot use the cloud. That's why I preface with your EPC. So mine at Red Zone, for example, is 312780. That's mine. That's my identifier nationally. You have to re-register it every year. It's a couple $100. No big deal. But then you can burn your own SIMs. You have them made. I had mine customized. Had a pretty Red Zone logo on it. Things like that. But it works in any device I want. It's my PLMN. I control everything. But when you have your own EPC, particularly one that's mobility enabled, you can allow other PLMNIDs. And I actually graphed, just so I could show my investment group what I was getting. So I could graph all the denies. I had 13,000 devices an hour from Sprint try to attach to my network. I had 8,000 T-Mobile and about 6,000 combined between AT&T and Verizon try to attach to my network every minute. And it's just get denied at the core. And I could graph all that so I could take to my investors and say, this is why we need to have an agreement with these guys. They want in. They're trying to attach to our network. Let's get them on. Let's start charging them some money. You know, so this is all stuff you can do with your own EPC. There's so much advantages to it. And getting your own PLMNID would be that step once you get an EPC of your own.
But remember, you know, adding your own EPC is something you can do down the road. You don't have to start that way. There's no...
No, definitely come in. Like if you're looking to get into LTE, you're limping in, you can always migrate your SIMs, and you can have multiple PLMNs. So if we have ours, when I say ours, Baicells, we can take those same SIM cards that are already in the field, we can get you and load it into another EPC, and it'll still work. It's not going to not work. So we have all that functionality available.
So how much time you have? We have lunch set up at 12:30. How much time you need to go?
That's essentially it.
All right.
How you like them apples? Any quick question, guys? Or no, nothing's been quick, but I like the questions before we go break for lunch. I thought we were going to do it after lunch, so I wanted you fueled up before we got into this.
Cameron, I want to make sure you and the gentleman with Gulf Coast, you guys get each other's cards.
Yeah,
I have
absolutely.
a feeling we'll be talking a lot to you.
I'll be out here, guys, in the hall. Yes, sir. That one? No. Okay.
With heavily wooded areas?
I wouldn't say they necessarily help. So what you're doing is you create less cell edge issues, but you're only going to lose, you know, when you're at 90 degrees, depending if you have a 3 dB roll-off antenna, you know, you get at 120s, you're going to roll off 3 dB. So you're losing 3 dB. There's always a trade-off by tightening your PEMs. You may lose some coverage. Very unlikely, though. I mean, it's quite unlikely that you're going to lose some coverage respect to what you would have picked up in interference. So you got to keep that in mind. So you may have coverage from an RSSI standpoint, but your CINR may just go right in the toilet if you're overlapping too much. Yes, sir. Armando right there as well.
What is the recommended height to have the devices at?
The recommended height?
Yeah.
Well, the default answer, probably by most people's room, as high as you can get it.
But I mean,
right?
like,
it's going to depend. Like in a small cell environment, you're going to be deploying probably less than 50 feet. You know, it depends if you're where Tim is. Where Tim has a pile of trees that are 3,000 feet tall. I'd want to be under the canopy and shoot through the trunks instead. I wouldn't want to be up in the canopy.
I mean,
I can't recommend one to you.
I'm in Louisiana, and one of the problems we have is obviously trees and vegetation and stuff like that. And I just deployed one to start testing it, and I can get more than 2.5 miles maybe.
I would say, depending on the scenario, I'm not going to be entirely surprised. There's been times where I've deployed band 41 at 10 watts, and I couldn't get 3 miles. So you're going to run into those situations from time to time. This is not a damn thing you can do about it other than just try to find another site to put it at. So there's no one size fits all. You know, that's kind of the reasons. Like when I use my ATOL software, which is what I use, it has features such as the auto PCI planning, auto frequency selection, and also can do, like if you're doing a complete greenfield deployment, it'll do auto site selection. So you can import a database of tower sites available, or you can say, I'm going to do raw construction, and it'll just go and say, if you want coverage everywhere, you want to meet these metrics, this is where you put your sites.
Dennis, I think you guys might even want to think about that as a service, get some of that software. Are you?
I think he's been over there thumbing away the whole time. So.
All right.
Do antenna arrays have to be completely symmetric?
They don't have to be. There's many instances where, like, if you're not deploying, like I had a lot of islands in the coast of Maine. Not a shocker there. I didn't really have a need to point my antennas towards Italy. So I just put a couple up facing back towards the coast. So no, you don't have to be completely symmetric. I would, like if you're trying to cover 360, try to be. Otherwise you can create some headaches for yourself. A follow-up question, I like it.
So
what I meant was, like, can you put one antenna that covers 90 degrees on the back and maybe 4 at 60 each on the front or something like that? I
see where you're going. So I'm going to say yes, but let's talk about it. All right? I know what you're trying to accomplish, because you may have one area that's got maybe 10 customers on the backside. You don't need to put a bunch of Node Bs up. So let's put one up to cover that area. And the other side is like, 50,000 people. You need to cover as many as you can get away with. So can I put 3 or 4 that way? Short answer is yes, but it requires planning. Planning, planning, planning. You cannot put enough time into it. I would not lie to you guys. Put time into your RF and PCI planning. Get it right.
So at